Welcome back. I'm Clayton Williams, Managing Director of IQT's London office, where I'm here today with Lorenz Meier, co-founder and CEO of Auterion, and Rob Rainhart, the current Chief Operating Officer at Auterion. This is part 2 of our interview, so if you haven't yet checked out part 1, I highly recommend having a listen there first to catch the context. Okay, part 2. First, some facts to set the scene. According to the Kyiv Times, Ukraine's drone production has increased by 900% over the past year, with monthly UAV outputs reportedly jumping from 20,000 units in the summer of 2024 to 200,000 units currently. Additionally, Ukraine is looking to buy and use 4.5 million FPV drones over the next 12 months alone. While the bulk is impressive, so is the complexity. We also saw missions like Operation Spiderweb on June 1st of 2025, which had Ukraine's coordinated attack on Russian air bases, and that was followed up by perhaps even more comprehensive and less reported strikes by Israel during the Iran 12-day conflict. Globally, everyone is paying attention. A recent report from the Research Institute for Democracy, Society, and Emerging Technology stated that Taiwan produced less than 10,000 drones in the last year, but has plans to reach 180,000 by 2028, which would be a 10x drone production improvement over those 3 years. Back at IQT's mothership, Secretary of Defense Pete Hegseth announced a new plan to ramp up American drone production and to improve the capability for American-made drones. We last ended the podcast at 2022 with the onset of the full-scale invasion in Ukraine. As a response, Lorenz, I think you packed your bags and headed to Kyiv. Can you describe what decisions you made at that time and how those decisions changed your business?
So I think the biggest decision is that we initially didn't consider ourselves particularly competent at weaponeering. And also during the first year of the war, it looked like the answer would be Javelin and NLAW. But then very quickly things started to change. I saw more and more footage of FPV drones being used. And then something really interesting happened because I assumed that the Ukrainian industry would evolve a little bit like what I've seen before in our case, and they would become AI guided and pretty fancy within months. And that didn't happen. And that's when we realized, actually, maybe we do know something about weaponeering because we know something about computer vision on drones and autonomy. And things like, for example, providing terminal guidance, which gives you the ability to lock onto a target like an anti-tank guided missile and turn a drone into a fire and forget system. And that's when I felt like, okay, there is a need. We can provide something. And us not throwing our knowledge into the fight is the equivalent of withholding technology from a democracy that defends itself. So we've got to do that and not just adopt that, but also I had to go there. I like to lead from the front. And so we had to be present in country. And I made it a point to have a very regular rhythm in Ukraine and also bringing the right level of humility with it, because if you are regularly there and you learn, you realize all the things that you don't know. And you hear all the stories about Western equipment that is failing and overpromising. And so we adopted, which I found out later on is like exactly the forward deployed engineering approach from Palantir. Not being particularly familiar with that, we adopted the exact same approach, which is basically, let's get something together quickly, get it operationally tested, by units that trust and are willing to take the risk that our kit doesn't work, and iterate really fast in a 2-week cycle. And so we did that for about half a year until we felt like it's ready for deployment. And then we've been ramping deployment ever since, from dozens to hundreds to thousands to now tens of thousands. And that, interestingly enough, is in the great sea of analog, manually piloted drones in Ukraine, some of the most advanced technology. It's not the highest number just yet. But if we look at, and that's a shocking piece, if we look across NATO and Western forces, it is the largest number of systems built by a single company. And we're making software and the avionics and AI chip. So we're not making the whole drone, but nobody else is operating in the tens of thousands just yet. And that is actually alarming. And that's also why we felt, hey, we have to be in Taiwan way earlier than in Ukraine. The much I enjoy being in Kyiv and like experiencing the urgent need and feeling that is a regular calibration that's important. It's actually better to help an ally in peacetime, and that's why we have been regularly to Taiwan and have announced our partnership with Taiwan recently.
That's really interesting. So, Rob, this falls, I think, well into your arrival at Auterion. So, obviously, very, very active in the Ukrainian ecosystem, very active in the U.S. ecosystem, scaling up production across Europe. When I look at the conflict in Ukraine, and I contrast that against the conflicts that Israel's undergone over a similar period. And then the potential of conflict in the Indo-Pacific, very very different conflicts. What do you think is something that you'll definitely take away from the conflict in Ukraine, and that's absolutely true across all battlefields, versus something that you think is actually quite unique to how that conflict is unfolded?
I think there's a couple things that come away from Ukraine that apply to other areas. And by the way, you said it at the opening of this podcast. The world is watching, and they're taking note for their own strategy changes, right? Hegseth, the Defense Department, is changing their strategy here relative to operational needs. And you see that occurring in Europe through other defense forces, and we see it in Taiwan and the broader Pacific region. So the world has seen the paradigm shift in terms of what the battlefield looks like and what needs to change in their own operational concept to be able to do that. So what comes away from Ukraine is that fundamental foundation that traditional approaches there are really not valid, particularly for the close-in frontline battles, right? Drones have changed the whole dynamics in terms of the operational efficiency at a price point that's hard to really not notice and focus at. And that's the critical piece. And that comes and applies. What's very specific and tied to Ukraine is the dynamics between Ukraine and Russia and how they're both entering into that drone leveling up situation simultaneously, right? Because you see Russia using different tactics and advancing the drones. There's a whole bunch out there about the Iranian Shahed that they're leveling up in terms of its capabilities. So you see this gamemanship going on there. I'm not convinced that every other regional area of conflict, both sides are kind of pairing to meet each other like that, right? Certainly China has been investing in its capabilities and resources there. So that scenario of leveling up is unique to the battle that's been occurring in Ukraine there.
Let me interrupt. Is that a consequence of maybe did we hit too cheap of a price point, where now we're looking at quality, and quality comes with a cost associated. Like our battlefield, is the feedback that this needs to work 100% of the time versus 20% of the time, or how do you guys see the need for a mission to work every time versus the ability to have something cheap that you don't care if you lost it, I guess?
Yeah, so I'm going to break that down just a little differently. I mean, I think the end goal here is that this works every time, right? What I think you have forgiveness in is that there might be impacts that affect its effectiveness, but there's a price point where you can always have a second, a third, the swarm effect, which we haven't mentioned yet in these conversations, but is really there. I think one of the things that we start to see, right, is if you really think about it and you have operator to drone, if you really want to get this to scale, you've got to be operator to many drones. and that's the swarm effect. And so then that lowers any one failure probability there. And so then rather than trying to put the price and the cost into making one survive every possible scenario, you have many with a percentage that get taken out for countermeasures or whatever else there. So that's the way I think we think about those aspects of it there. Lorenz,
maybe I can
was going to say, Lorenz,
chime in here. I want to tell
guarantee you Lorenz has a few thoughts there too.
No, I think this the important thing is, like, if you look at what is being used in the end for mobile devices by governments or first responders, it's not like there's a better phone for government. And in fact, government tried that and came back, says, like, these commercial phones are actually pretty good. And I also want to tell you a story that's straight from Kyiv. Like, a member of the general staff there told me, one of the most unreliable systems, I will not name the brand, but is a loitering munition, and its weakest point is the trigger, because the trigger has a fixed inbuilt battery to launch it out of its container, and that battery degrades, and you cannot swap it. And so they ended up with 10 of those loitering munitions, and with, out of the 10, one trigger that worked to launch it. And so they had to run from one to the next to launch them. And that is a very exquisite, very expensive system. And it's stuff like this, low rate production, like not enough extended lifecycle test, overaged equipment because it was so expensive that we can't afford to decommission it that quickly. Where it's like, no, that stuff, and don't get me even started on the stories about how those systems performed when GPS was jammed. So that's such a good example where I think we need to get away from the notion of, hey, it's exquisite, so it's good. That is true for high-end aerospace. It is not true for so much of the, I would say, like Group 1 to Group 3 drones. And the rapid iteration that we're seeing in Ukraine now, and the fact that also NATO and US forces can afford to rapidly iterate if the systems are designed to be attritable from a price point, leads to a completely different level of kit. And so we need to get to a point where US commanders are happy to basically dump their current inventory of drones into training exercises and buy new ones next year, so they have the latest kit, and it's up to date and not overaged and doesn't have old batteries that stop working.
Well, let's pull on this thread a little bit, because I think we kind of hinted about it in an earlier part of this conversation, and that's all the Western kit that was dropped off at the border at the beginning of the conflict and said, "Good luck, you can take this and win the fight." I imagine a lot of that, the story is none of that worked, right? And I think that's pretty well proven out. But a lot of its capable technology, it just had a poor radio, or it's capable technology, it just had a poor, software application to switch over off GPS once you're being spoofed, right? Or it's not fit for purpose as a loitering munition, but as an ISR drone. So there's kind of this excellent innovation, but terrible product market fit, I guess I would maybe describe it as. And it strikes me that a lot of those are kind of what you described as a vertical platform that's very efficient, very precise in its implementation, but not very flexible. Obviously, you guys are doing something different. Can you kind of talk about I guess the benefits there? Because there's also challenges. Over-the-air updates across a exquisite number of variables is always difficult, but maybe you can talk about horizontal versus vertical implementation. Lorenz.
So let me zoom out for the audience and quickly explain, and again, in a nutshell, what we're doing. We're building a common operating system with apps, and these apps include hardcore military things like terminal guidance into a target. And so it's a very, very unique, different approach where we're basically saying, look, all of the drones can run the same operating system. You can upgrade them with the same applications, so they now all have terminal guidance, and we take care of the subtle differences between those different airframes. And they might look very different, but to us, they're actually subtle differences. So the benefit of that is you learn one thing on one platform and you can apply it to all. So if you learn about spoofing or jamming on your ISR system, the loitering munitions you're going to bring into the fight 2, 4, whatever months later, they're already upgraded. It also is really, really important for swarming because it's hard to coordinate a complete kill chain if every single system has a different API to hand over targets, for example, or if you have between 5 or 6 companies first to agree on an interface standard, which by experience, in particular in our industry, will take 5 years. Good luck doing that during active warfare. And so installing the same software solves all this. The challenge, the slightly harder challenge, but that's mostly on us actually, that's not something the customer experiences, is, well, you have to convince all these companies to partner. So we are the company that believes in alliances, that believes in collaboration, that believes that the network is the weapon and it's not so much the individual system. And that requires convincing, and that also requires customer pull. But we are seeing more and more customers who are basically buying what we provide, our software and also the integration kits, as government furnished equipment, and turning around to industry and saying, like, look, for us, it's more important that it's all nicely integrated and effective as a kill chain and even scales as a kill web than you bringing your one bespoke feature. Because that doesn't make the difference. The mass makes the difference, and that's what we're providing. We're providing autonomous mass.
Yeah. Okay. Really interesting. There's 2 follow-ups I think that inspired. One is swarming, which we've hinted at here now twice, and that'll be the second question. The first question is really the increasing complexity. So you know. I think there's a lot of companies that are trying to build a drone that can be launched and take out another drone or a fast-moving object by itself, right? So it doesn't need a ground-based radar. It can do everything in the nose cone, and it's doing this phenomenal job. It seems to me that that's still very much in development, and so the need for these complex, command and control systems, tip and cue systems, a radar that cues an optical system that cues a fast-moving system, all these kinds of things are kind of playing out. Rob, can you talk about how Auterion will play in this environment and how the horizontal solution is required, not just for the drone platform, but for everything around it to interoperate?
Yeah, I mean, it goes back to a little bit of what Lorenz said there. You have to have a standard mechanism that enables the communication protocol and a set of apps on board that allow this information, target handover, autonomous operations, terminal guidance, all the different pieces to have a flow and consistency to them across a number of different platforms and across a number of different scenarios. And the only way you get that is through that kind of open ecosystem there of that particular platform there. I think if you go back to the scenario you described just a few seconds ago, where you've got, one-to-one versus one-to-many, there's a level of autonomous operation in the one-to-many that's really, really important. And that level of autonomy applies in GPS denied environments, and it applies in the command and control aspect and approaches there. And it applies in terms of how you make the target decision, target handover, and the path of that decision in the coordinated entity, right? And the only way you do that is through that platform that enables those communication and those different apps to reside across there. Otherwise, everybody's target handover or there will be subtle differences, and you won't be able to work across platforms efficiently or effectively from an operational perspective.
Got it. Okay, so like it's clear to me that Auterion is a leader in that, but government also needs to play a role in providing kind of clear breakpoints between all their vendors, right? In order to enable this to come to fruition.
Exactly. And if you go back to like a vertically oriented end-to-end solution, right? You're not going to go out and buy a solution where you have swarms of drones control all the way back, and you're not going to buy that whole system as one complete system anymore. You're going to buy this as individual pieces. And by the way, on the expendable part of that, on the drone side, even ISR platforms at the price point ISR platforms are at, ISR platforms in Ukraine last 30 days, right? So there's still a refresh rate even on those ISR platforms, right? So on the expendable side of this, you're going to be evolving, adding new capability, reacting to that without wanting to have to redo the entire system or the flow. There will be new vendors, new providers, new capability that you're going to want to ingest into your overall large system. So you're going to have that architected in a way that allows you to have the maximum flexibility where you really need it at the tip of the spear for the operation.
And so, okay, so we mentioned, I think we're hitting on something here because so swarming is kind of this golden goose, this dream, this thing that a lot of companies and people talk about. And then when you kind of get down into it, we're talking about fleet operations, we're talking about handovers, exchange of information, communication, and I think the main misconception that I see, and there's a question here at the end, is we think of a swarm of starlings that are all flying together, or we're thinking of a swarm of bees that are all attacking someone who got too close to the hive or something like that. But what you just described, I think, is actually what we're going to see or increasingly see is, no, this is heterogeneous. This is bees interoperating with birds, operating with a commander on the ground. Like this is a heterogeneous set of things interoperating with different capabilities. So in a way, it can't be vertical. Because you're likely at least going to have 10 different vertical solutions, offering different capabilities. So Lorenz, what is this? What are we seeing? What is the most complex, drone swarm-like interoperability? What are we seeing today that's real?
So it's quite funny because I see. Let me talk about swarming first. So swarming is like it's real because. What do you want to achieve? You want to achieve a coordinated strike on, let's say, an armored column or an air defense system. And you want to be able to execute that really fast and with a single operator, because otherwise it takes too much effort, and that's why it's not being done. Nobody's doing that today. Literally nobody. We actually have a product called Nemesis that we're keeping under wraps a little bit. We're flying swarms every day, and we're doing swarm strikes every day, and we will be very soon public about that. And the interesting thing is, as you start to think about that, and as you work through it, and as you have the right infrastructure in place, it gets really easy. So this is the new norm. It's not actually that fancy. It just requires a whole bunch of infrastructure like standardized communication, mesh networking, other things that if you are standard setting like we are is easy. If you're trying to retrofit that is close to impossible. Same thing as with smartphones, app stores, all that. And let me make an example why the proprietary architecture will die out very quickly. If you want to strike a target with a swarm with, let's say, different warheads, different capabilities, in order to not have interference on approaching and in order to maximize your effectiveness against air defense systems, you need to arrive on the target at the same moment, ideally from different directions. Which is, I'm anticipating gun-based air defense systems. You basically want to outmaneuver the swivel or rotation speed of the defense turret. And that requires now that you need to perfectly coordinate your trajectory planning. Also, quite frankly, to not crash into each other. How do you do that? Now you can go ahead and have all of the defense primes agree on the exact same trajectory shaping algorithm. And then you find out next month that it actually was a bad idea for this target set and you need to change. You're not going to be able to do that. So the only way to do that is to have the trajectory shaping deploy to the system regularly as an app. That's the only way you will achieve that. And so if that's the only way, now you suddenly have a hard requirement to be able to install apps on board across different types of systems. That's the only way how you will get common behavior and common motion. And that's now, in a way, making it inevitable to run a common operating system, because how else are you going to achieve that? And that's why I believe what drove standardization across computers was common training, but also that sort of interoperability, networking. And we're now seeing the same thing here for the first time. And based on what we are doing internally and haven't shown to the world yet, it's actually incredible how easy that swarm becomes to operate and how effective it is. And so I think it will be, we're going through an exponential curve in terms of the number of drones on the battlefield with this now. And it will serve as a forcing function to do everything on the edge, because spectrum dominance is gone. That's right now driving edge adoption of AI and other things, because we can't get videos through at high resolution fast enough. But swarming is going to be a much, much bigger thing. And you're hearing that from somebody who hates the term swarming because it means absolutely everything and nothing. But I think the mass adoption of drones is coming.
Well, you heard it here, guys. So whether this is a public announcement in the future or not, I think it's now a public announcement. So that's actually pretty exciting. While we're on the topic of the evolution, right? There's kind of a lot of pontification that we've been touching on. And another thing that I think is a term that gets thrown around, I think, quite cheaply as well, alongside swarming, is electronic warfare, right? An electronic warfare or counter drone is not one thing. It's anti-radar, it's anti-satcom, it's positioning. It's all sorts of disparate technologies. And as Auterions had to navigate that, how has that been both historically, and then how do you see it going in the future? And this one's to you, Rob. For the past question, how many radios, for example, have you guys gone through in the 3 years that you've been deployed in Ukraine? Right? How many different technology providers have you had to use?
Half a dozen different radios in terms of options. And for us, it's about having options, right? It's about having a flexible architecture that enables different options and capabilities, whether that's commercial off-the-shelf radio, something very special, or something we've built ourselves. And it's all about enabling options through different mechanisms there. And the comms link, low rate, high rate, denied environments, all about being able to support different options there. And then fold that back into our own capability over the long haul, but be backward compatible to other platforms, because different theaters, different customers, different situations are going to have different requirements and different needs for those. And there's no way we can anticipate everything, but what we can do is provide a flexible architecture that gives us the capability to evolve and adapt there. And that's where we focus.
Yeah. Okay. And I imagine there's probably a pretty intense, we would call it ConOps, and like a user guide for if this is your environment, then this. And I imagine that has to be co-developed alongside your software stack. So that way, I imagine there's probably a lot of feedback you get from the front line that maybe in the IT space we would classify as user error, where you say, well, why did you do that there? How do you kind of handle, maybe Lorenz, you're nodding your head and you spent time in Kyiv with these folks. So what was, How do you deal with that, or what was the lesson learned there?
I think it's the successes and fast iterations, or like it would be like you fail by death by 1,000 cuts, and it's like they might take off differently. They might take off close to trees, which Western operators usually don't have to do because they're not taking off new tree lines. The life is not centered on tree lines. It's totally centered on tree lines in Ukraine. GPS jamming wasn't prevalent in earlier wars. Spoofing in Ukraine is like everywhere, really high quality spoofing where the position stays accurate, but it's just the altitude that's undulating to try to drive drones into the ground. Stuff like this. So we were actually surprisingly resilient to a lot of that because we were just paranoid in our system architecture. Other things we had to learn the hard way. And I think to Rob's earlier point, you cannot anticipate that. The only thing is you can build a machine to iterate fast. And then most importantly, to apply learnings from one system onto your whole fleet. And that allows you to outpace the innovation speed of the other side. And I think in any near-peer adversary conflict that we might see in the future, that's the important thing. How fast can we iterate, and how wide can we deploy learnings that we're making in one part of the theater or against one type of threat?
So I know we're running out of time, but I do want to touch on this. So you mentioned different platforms and the changing. I mean, but you're also doing this across domains, right? So at the beginning of the podcast, we talked about starting with UAVs because that was the easiest environment for a computer scientist to envision. But now we're dealing with physical AI, I guess is what Elon or Sam Altman would call it. So can you describe how you guys are extending the platform for the maritime domain and for the land domain? Rob, this one's to you.
Yeah, I mean, I don't want to oversimplify it, but it's different apps that reside in the same ecosystem. So we have a boat control app with boat controls and boat capability there that integrates directly into USVs, and same thing with ground-based rovers. And we've integrated, the overall ecosystem into those, and it's, slightly different controls, different mechanisms, different user experience. Because what you're doing is very different. But we've abstracted that in a way to make it easy for the users to be able to, to interact with the system in very similar ways to they do to the drones.
I'm having a recall moment. Lorenz, wasn't there a jetpack user of Auterion back in the day, or am I misremembering that?
Yeah, so people have done all sorts of things with the control system that we didn't anticipate. I think we also have underwater vehicles and everything. But I think for us as a company, it's air, sea, land. The order in which we're rolling out, but we have like defense systems on TRL 7, 8, and 9 for all of these three domains, and I think like air and sea are hitting combat, and land will follow soon.
Amazing. I'm getting all sorts of messages that we're out of time, but I want to jump into a lightning round because what good podcast doesn't have a lightning round? So one sentence answers, try to resist adding more, but we'll go through each and see where we land. First one to you, Rob. The rising interest in VCs in defense tech, boom or bust?
I think it's a boom. I think strategies are changing, and there's going to be a lot of innovation that comes as a result of that. So I think it's a boom here, especially with the changing strategies.
Lorenz, over to you. Prometheus, which I'm guessing is no longer the benchmark it once was, but Aliens Prometheus is a movie from 2012. It started with these autonomous systems flying through, I guess, an underground or alien infrastructure, mapping, providing real-time intelligence back to users. It was kind of the science fiction gold standard for what a drone can do. How far away are we from a Prometheus-like drone?
So from a risk perspective, I'm not too worried about that. It's still users designating targets. And technology in the end is always less autonomous than you think, but I think the scale, the number of units, is bigger than we can imagine.
Sure. Great answer. Okay. Rob, we had the drone swarm question. So when do we see those fleets hitting the streets, operating with military systems in these kinds of conflict zones?
I think you're going to see all that start to unfold here before the end of 25.
End of 25. You heard it here first, everybody. End of 25. Lorenz.
Right now, the developers and the product. Right now, the developers and product teams are listening to this are panicking.
Yeah, I'm sure. Like any good product team, right?
Yeah, exactly.
Lorenz, biggest misconception today about what drones can do?
I think that the scale is underestimated. Again, like it's 4 million drones a year in Ukraine. Isn't like you cannot like fathom that. Like, so I think that's the biggest misconception. I think what drones can do, I think they're less autonomous in the current state than the general audience will imagine. However, the autonomous solutions are there and they're fielding quickly.
It's coming. Rob, which will I own first as a consumer? A robot dog or one of these humanoid robots from Tesla or the like?
Oh, I don't know. I'd say neither.
I think that's probably right. B2B, not B2C. Go ahead, Lorenz.
The robot dogs have come and gone. Let's see what.
Yeah, I was going to say robot dogs are over. So maybe a robot human, but I don't know.
It gets creepy quick, doesn't it? Lorenz, this is the walk-off question. So, what does Auterion look like in 2030, 5 years from now?
Mass scale, household name.
Amazing. So we're over time. Apologies for everyone who's hoping to get this done in a 30-minute block. But I do think it's the perfect question to end the podcast. Rob and Lorenz, thank you for your time. Listeners, thank you for having a listen. This has been IQT Explains, a series of the IQT Podcast. Subscribe for more. You can leave comments. You can visit our website at iqt.org, or you can go to Auterion's website at www.auterion.com or a battlefield or a flight test range near you. Thanks, everybody. Really enjoyed the conversation.